Joy is going to give us this amazing presentation, but please, Joy, the stage is all yours. Please tell us about yourself.
Thanks, Joe. Yeah, I will actually get to myself in a few slides here. So hold on. My dog just destroyed something. Sorry about that. Anyway, hello, good to see everybody. Yeah, so I'm Joe Reis. I'm going to talk about WTF is data engineering. So let's get started here. So why should you care? Well, if you're a data scientist, you need data upon which to do science, right? Data science. But the big question is, how do you get this data? And even if you have the data, right, can you rely on the data? Is it good? Should you trust it? I mean, I think the bottom line is, do you have the data to do your job and build something great? So show of hands here, who you can maybe raise your hand using the Zoom reaction. How many people are data scientists? Cool. How many people have heard of data engineering? Cool, awesome. All right. Well, cool. So anyway, what we'll cover today is we're going to talk about what is data engineering, who was a data engineer, the data engineering life cycle, undercurrents of data engineering, who a data engineer works with, and then we're going to bust some myths about data engineering. And then we'll have a Q&A. I would say if you want to ask questions in the meantime, feel free to do so. I'm happy to answer them as we go along. So who am I? I am a recovering data scientist. I've been working in data since the early 2000s in many capacities, analytics, machine learning, and so forth. Got into data engineering around, say, the mid 2010s, which we'll get into in a bit. But my day job, I'm CEO and co-founder of Ternary Data. We're a data engineering consulting firm. I also teach at the University of Utah in the United States. As far as content goes, I host numerous podcasts, I speak at conferences, I blog, and I'm also the co-author of an upcoming book on O'Reilly called The Fundamentals of Data Engineering. Shameless plug, Fundamentals of Data Engineering. The first 2 chapters are actually available now on O'Reilly.com. These are the early release chapters, so they're raw and unedited, which means please don't think this is the final chapter on them. They're simply the drafts, but I think you can, so far the response has been overwhelmingly great. I've heard people say the way we've described data engineering is probably the best description that's out there right now. So not to, brag, but I think that we did a pretty good job at explaining what data engineering is. So if you have an O'Reilly, if you have access to O'Reilly, go check that out. And this will be out in 2022, the complete book, by the way. Well, okay, so let's dive into data engineering. So there are lots of definitions. One definition is data engineering is the science of collecting and validating information such that data scientists can use it. Another definition is data engineering is all about the movement, manipulation, and management of data. I did a quick Google search for the exact search for what is data engineering, and I think I came across over 90,000 results. So no shortage of opinions. In the chat here, maybe for the next minute, you can throw in, what do you think data engineering is? Why don't you type that in the chat here and we can go over that real quick. I'll give you guys about 30 seconds to a minute. Again, I'm just asking you to type in, what do you think data engineering is?
I think a data engineer, I want to say my opinion, Joy. I think that data engineers are the ones that prepare data. They help us to organize data, and then we can, data analysts, data science, we can do our job in a better way. So without data engineers, I think data work couldn't be so amazing as it is.
Yeah, I think that's actually accurate, Gio. Seeing some definitions or thoughts about it. I think these are all good. I'm seeing something along the lines of governance, manipulation of data, validating data, collecting data, and so forth. I think these all encompass various aspects of data engineering. Let's hop into my definition of it. I think that me and my co-author Matt Housley, we see data engineering as a bit of a long-winded definition, but basically you're going to develop, implement, and maintain systems and processes that take in raw data and produce high-quality, consistent information that supports analysis and machine learning, among other use cases, right? So basically, you're going to get data, do something useful with it, and then make it useful for people downstream. And I noticed that there were some people have thrown out data governance and cleaning and validating data and so forth. I mean, these are part of the undercurrents of data engineering, where you're going to manage your data. This includes data governance. You're going to operationalize your data pipelines in such a way that they follow best practices, kind of similar to what you do in software engineering with DevOps, right? Or ML ops if you're in that space. You got to know data architecture and implement data architecture best practices. You'll be orchestrating workloads, and you'll be using software engineering. So all these things sort of undercut data engineering as well. So let's take a step back. Let's go through a history lesson. I mean, how did we get here, right? So basically in the 2000s and before, you had jobs mainly centered around data warehouses. So how many people have used a data warehouse? Just a kind of show of hands real quick. So a few. Cool. So data warehouses, I mean, they're still widely used today. Basically what they are is a way of consolidating information for business analytics and reports, right? And so, I mean, reports have been around since the dawn of time in some way, shape, or form, right? And so, but really around the 90s, you started seeing this term data warehouse pop up, first from Bill Inman, I think back in 1990. And then it became an industry kind of on its kind of its own. Pipelining data mainly from your transactional systems into a place where you could again generate pretty common reports. You had titles like ETL developer, extract, transform, load is what it stands for, DBA, BI engineer, data warehouse administrator, and so forth. And so these titles, they're still around for sure. And there's still companies that do this kind of stuff. And I'm going to make we'll circle back on this part in a bit. But what happened in the late 2000s and early 2010s was the big data revolution. Does anyone know what big data was or is? Heard of it before? Yeah. So big data, I mean, it was meant to describe, the explosion of methodologies to, analyze, transform, manipulate, large data sets, right? So kind of what happened was you had the explosion of the internet, and the explosion of the internet meant a lot of data all of a sudden, more data than these traditional systems from, the 2000s, traditional data warehouses or transactional databases could handle. So suddenly you saw, new revolutions like MapReduce, which came out in 2004, I think, from Google. Subsequently, technologies like Hive, and Presto and so forth really became like these big data technologies, Dremel and so forth, right? And so big data engineer became a thing. And mainly these engineers spend a lot of their time managing, kind of Hadoop related stacks. Has anyone heard of Hadoop? Cool. Yeah. So it was like kind of the first, I would say, like real big data paradigm. Big data really stood for, the 3 V's of data, right? So velocity, variety, and volume. And so you had just a larger amount of data being produced, more variety than you'd seen before. And it was growing at an ever faster rate, as well as being sent at an ever faster rate. So you started seeing early variations of real-time data starting around this time as well, and systems that could handle that. But what happened really around like 2015, 2014-ish Cloud data warehouses became kind of a thing again. You know, so you saw AWS Redshift, BigQuery, Snowflake, and so forth came out. And also along this time, data science became popular. So when I got into data science was not a thing. It was not a title. Nobody was really doing machine learning back in the 2000s because you didn't have the computers to do it. I mean, Excel, for example, had like a 65,000 row limit back then, which would show you, because the computers would just conk out after that. So that should show you kind of the state of technology in the 2000s. But around the 2010s, GPUs, you know, cheap memory, cheap storage became a thing. So cloud computing took off. And at the same time, data science took off. I remember in 2011, I think it was, Andrew Ng had his first Coursera class in machine learning. I think that opened the floodgates for a lot of people to get interested in machine learning. I think that initial class had 100,000 people sign up, myself included. I thought it was really cool. I mean, I'd always been interested in machine learning, but you know, now you could actually do it at scale. And so this really took off. And then data engineering sort of went alongside it, this data science revolution. You know, and right now you see titles like analytics engineer, machine learning engineer, and I'm sure, you know, throughout this decade, there'll be plenty more titles that are yet to be invented. So it's pretty cool to see the progression. But at the end of the day, you know, what's happened is you just have bigger and better ways of making data accessible to analysts and data scientists. Really, what, you know, what's happened. So, who has seen the data science hierarchy of needs image? Well, let me explain this to you real quick. So this is actually from Monica Ragati. I think she published this in 2017. And what this is it basically illustrates, I think, sort of the progression, you know, of a lot of data practices. Most companies want to go to the top of the pyramid. You know, they want to do AI and deep learning out of the gate. How many of you have seen companies or seen friends or organizations just want to jump straight into doing deep learning and machine learning? Yeah, yeah, exactly. Yep, a lot of people. So yeah, this is the temptation, right? Is you want to just jump straight into doing deep learning because you hear it's awesome. You hear it's, you know, everyone should be doing it, therefore I should be doing it. So this is what happens. Everyone wants to just jump to the top of the pyramid. But what do you think happens if you take this approach? If you don't build a solid data foundation, sort of the bottom tiers here, what happens is, your AI and machine learning suffers as a result. I mean, I call myself a recovering data scientist precisely because I've been personally, involved in projects where this has happened since the early 2010s. I mean, when I worked at an early automated machine learning startup back in 2012 through 2014, and I'd seen this firsthand. We had a really good way of automating the use of algorithms, which I think the algorithms is actually the easiest part. The engineering before and after is actually the hard part. So engineering the automation of featureization of data sets, that's really hard, actually, with structured data, especially when you can't see the data beforehand. And then productionizing your models and making sure that you're tracking the ability of your model to detect drift, or detect drift into your model and so forth, right? That's also hard. And so around that 2014, 2015, I was like, well, I think I want to focus on making robust pipelines and infrastructure, and that's when I changed my focus to data engineering. I don't think it was a term back then, but that's just what we had to do out of necessity, because if you hadn't built the right infrastructure, the things at the bottom, the rest of it didn't really matter, is what I found out, right? So you can have the coolest algorithms in the world, be training the nicest models, but really, and that's great if you're doing it on your own. But if you're building production level machine learning, you absolutely have to build these bottom pieces here: good infrastructure, pipelines, transformations, and so forth. Any questions so far? Yeah, as Fabio says, garbage in and garbage out in the comments. Yep, exactly. This is the tautology of data. So let's talk about what a data engineer is then. So we talk about data engineering as a discipline, but a data engineer manages the data engineering lifecycle, beginning with ingestion and ending with serving data for use cases like analysis and machine learning. But notice these three words here: data engineering lifecycle. These are a bit of loaded terms I'm going to get to in just a second. So I see people raising their hands. Are those questions or reactions to the prior stuff? Just wanted to make sure. Cool. Like I said, if you have questions, feel free to unmute and ask a question, or just ask it in the chat. Either way. So what does data engineer do? We kind of covered this, but really what a data engineer does is they get data from source systems, they make it useful, and then they serve it to downstream users. That's basically about it. So to make this a bit more clear, let's talk about the workflow, right? So I got source systems over here. These could be APIs, transactional databases that your company uses, databases that are used for your applications and so forth. These generate raw data, which are then used in data engineering systems and processes that create data models that are then used in data science and analytics down here. So data engineers really focus on getting the raw data, building the systems and processes to process that data, and then making that data useful in the form of data models. I know that word models is a bit of a loaded term, but we'll get more into that in a bit. But really, data engineers focus on the areas in the green here. So who's heard of data life cycles or have seen charts like this before? So this one's from Harvard. There's no shortage of data lifecycle charts. If you Google them, you'll find like a billion of them, most likely. I think everyone has their own idea of a data lifecycle. Really, though, at the end of the day, data gets generated, it gets collected, it gets processed, it gets stored somewhere, and then other things happen to it. You might manage it, you might analyze it, visualize it, interpret it. What's not on here is obviously machine learning, right? But you kind of get the point. You got to get data, collect it, do something with it. This happens in anything related to data. You could store the data, right? But then that doesn't do anything, right? So you got to have a game plan for it. So this is a new idea that we have in the book, the data engineering lifecycle. So you're basically going to get data from, source systems will generate data. You're going to ingest that data, transform it, and serve it. Notice that storage undercuts all aspects of the kind of the verbs, so to speak, of the data engineering lifecycle: ingestion, transformation, serving. At every point, you're going to be storing data in some way, shape, or form. But then, you're going to serve it for downstream use cases, machine learning, analytics, reporting, and reverse ETL, which is actually not on here. But undercutting all this, all the way through, things like data management, orchestration, architecture, ops, and engineering. So, and really the undercurrents are fascinating as well, right? So when you talk about the undercurrents, what you're really talking about are things like data governance, right? So just discovering your data, checking quality, making sure it's secure, making sure there's ownership and custody, making sure there's ethics, bias and all that kind of stuff with your data. Data ops, right? So automation, monitoring, and incident response. This is the same as DevOps. Now it applies to data. Data architecture. Architecture is a very interesting term, actually. When you think of architecture, it's actually a very fuzzy word. Can anyone take a stab at what they think architecture is? So I had to think a lot about this one, actually. It's sort of the design of systems, right? I think to serve business goals. Nartek says the plan related to something. Yeah, exactly. But it also involves, basically there's no such thing as great architecture. There's only like the best of worst architecture, if you know what I mean. So along the way, you have to be really good at trade-off analysis, right? So if I have a set of constraints and a plan, right, and some goals, what am I trading off in order to get that, right? So as a data engineer, you really got to consider what are the trade-offs of what I'm trying to do, right? If I use this pipeline for my data, what am I missing out on if I do that? Which means you got to design for agility, design for reversible decisions as well. So you want to build something you can maybe get out of at some point, which we'll also touch on in a bit. Now, obviously, you want to add value to the business, right? I think it kind of goes without saying. Everyone talks about adding value, though, and I think value is also one of those loaded terms that people say a lot, and I don't think they actually know what it means. So when you hear the word value, just as an aside, whether you're a data scientist or a data engineer, always ask what that means. Like, what do you mean by value? Like, what's valuable to you? Oftentimes, you'll find that it's something quite different than what you might think it is. So then another part of the undercurrents, you got to orchestrate, right? You got to coordinate workflows, schedule jobs, and synchronize data and metadata and so forth. And then finally, software engineering. I think this is an undercurrent that even though there's increasing abstraction in tool sets, you still got to know how to write good code like a software engineer, right? So this means like using the best design patterns possible for writing software. It means knowing how to test and debug and knowing the big picture concepts of software engineering. So who does a data engineer work with? Well, again, if you go back to the life cycle, obviously you have sources that generate data, and then you have people that consume the data. So upstream, the people that generate the data, those might be software engineers, application developers, who work alongside product managers, project managers, and so forth, right? Or it might be third-party companies that generate data. You need to work with all these people, develop good relationships with them, because you rely on the data they provide, right? So downstream, the people who you're going to be serving data to, these are data analysts, data scientists, ML engineers, and ML ops practitioners as well. Depending on the data maturity of a company, the ML ops engineers and they might be the same thing as a data engineer. And then obviously the business, right? So these are the executives and stakeholders who use your data or your models in order to generate some sort of an outcome. So who's worked with the business before? Anyone worked with the business? Yep. And as data scientists, which I'm assuming a lot of you are, how did that work out? Do you have a good relationship with the business, or what is your relationship like with the stakeholders? So I know in my own experience, feel free to type it in or just blurt out something, work closely. Yeah, exactly what Giorgio says. I think you want to work closely with the business. At the end of the day, everyone needs to be aligned to the outcomes. What I see happening with data teams that don't do too well and aren't that successful is they try and operate in a vacuum and just do things on their own, right? So it's not really a good recipe for success, but it happens more than you think. So, and also the business usually controls the budget for your team, by the way. So just FYI. Cool. Let's talk about some myths. I mean, data engineering, it's a very hot field. I think there's some myths around data engineering. So let's get into it. Oops. So myth number one. How many people have seen some form of this myth where data science is better than data engineering, or data engineering is better than data science? How many people have seen some form of this? Nobody? Okay, cool. Well, must be nice over in Italy. The US is much different. Yeah, Feda says, I think we can't separate both. I do agree. I think these are, one relies on the other. Every time I see data scientists trying to do their job without proper data pipelines or infrastructure, it doesn't really work out that well. Yeah, Lucas says, I think one needs the other for making valuable their job. Yep, agree. So I saw this kind of breakage or the split back, especially in the 2015s when data science was in the or mid 2010s when data science was on the rise. I think there was almost kind of a form of elite thinking with data scientists that they could just do everything and they didn't need engineers. Then I saw very few data scientists actually doing things in production. And the successful data science teams that I saw had data engineers on staff. So that kind of answered the question for me. You need both, right? Data engineers without data scientists or downstream users or like analysts, I think, or they're not doing anything. You're just making systems. But if you're making systems without some sort of outcome, it's kind of a waste of time, isn't it? So I think they're each one needs each other. So here's another one I see is data engineering is a big data tool. So it's Hadoop or Spark or a stack, right? So the data mesh or modern data stack. How many people have seen some form of this? It's kind of like I think it's saying that data science is TensorFlow or PyTorch, right? You see these same sort of arguments happening. Has anyone seen some form of this argument in either data science or data engineering? Yeah. I guess when you got into machine learning, I mean, how many of you bought tutorials like, learn data science with PyTorch or something like that? Yeah. Yeah, same thing in data engineering, frankly. I see a lot of tutorials and courses like become a data engineer by learning Spark. I think these are not great approaches to learning data engineering. I think what it means is you're going to learn a tool, but you're not going to learn the underlying principles of the field of data engineering. So, but there's a lot of false equivalencies, if you know that word, between tools and stacks and in a discipline. Like I said, you see this also in data science pervasively, I would say, right? It's like learn Python for data science. And like, that's not the same thing at all. So, or learn R for data science. And so these are kind of silly arguments, but they happen a lot. So just when you see this, always ask like, what more is there to the field itself, right? How many people know what a FANG company is? It's like, basically it's an acronym for Facebook, Apple, Amazon, Netflix, and Google. So what I see a lot happening is there's sort of this belief that if a FANG company does something, in the data field, I need to be doing it too. So this usually happens when people are reading like the Netflix blog or the Google blog or Facebook and saying, well, because they're doing it, it obviously will work for my company. And I got to tell you right now, your company is not Facebook. It's not Google, unless you work there. But most companies aren't, right? Like these companies, Google, Facebook, Netflix, they develop these technologies because they had to, right? Their needs are so specific that they really have to develop internal technologies that fit their needs. How many people have seen some sort of variation of this argument before? I guess how many people read Facebook's or any of the FANG blogs for their data science teams? Cool. Yeah, and they got some great blogs, by the way. I mean, they're awesome. Really smart people working there. But I would say the thing that you got to always remember is like, unless you're working at one of these companies or a company with very similar requirements or technology or expertise or teams, like you shouldn't be doing what they're doing. They do this for a reason. It's because they have to, not because they want to write cool blog posts. Well, they might actually do that too, but I kind of doubt it. So, sort of along those lines, there's a myth that data engineering is only for big companies. I would say this used to be true actually in the big data days when you were dealing with large Hadoop stacks. The only companies who could afford to do that at scale were big companies, right? But now with the advent of new technologies, everything's become cheap and accessible. You can do great data engineering and great data science for a very affordable price. The myth is I'm trained as a data scientist, so data engineering is not for me, either because it's not for you or because people tell you that you don't have the skills to do it, right? I've seen some people say, data scientists, I've read articles where people say data scientists can't be data engineers because they don't know how to program. Has anyone heard this argument too, where data scientists don't know how to code? Yeah. I see this a lot too. I think this is, it's a bad argument, right? I think data scientists, are very smart people, almost by definition, because to learn this field, you have to be smart. Like, and so it's not to say like, because you're a data scientist, it means you're somehow inferior and can't code. I think that elitist viewpoint is wrong. I know plenty of data scientists who have become great data engineers. And I think it actually gives you an advantage in some ways, right? Being a data scientist, and this also includes being an analyst, which I lump into data science these days. You know that you have something that I think engineers don't, right? You understand your data and you understand the domain. And what we see is a lot of data scientists end up doing data engineering, building pipelines, data warehouses, data lakes by necessity, because there's no one else to do it. They try and get software engineers to do it. It doesn't really work. And so I think if you're trained as a data scientist, you can become a data engineer. And what I see happening right now too is, although data science is still a hot job field, data engineering is actually taking off, to the point where I think it's actually going to eclipse data science soon in terms of popularity and pay. I think for pay, it's already happening actually. So if you really want to make a lot of money, go to ML engineering. I think that even pays more. So let's say some current trends happening in data engineering. It's obviously maturing as a field very rapidly. It's come a long way since the big data days of a few years ago. It's also moving cloud first. The number of companies that I see starting their data engineering, their data science efforts on-prem are just rapidly declining. Back when I got started, you had to do a mix of having your GPUs sort of on your own server, just because the cloud wasn't there yet. Now that's changed. You can get very great hardware for very cheap in the cloud. I still think that if you're doing prototyping for machine learning, like you should have your own GPU. I think it is more cost effective to prototype stuff, but for production, I see most workloads moving to the cloud. Like I said, I think there's a move from big data to just data. So I don't think that the term big data is relevant anymore. I don't think it ever was, frankly, but I think it was a nice marketing term for a bit. You're starting to see more of X as code. So a lot of things like DBT, Airflow, Great Expectations that are essentially just code libraries that you can use to manage your workflows through code. This is a big break from monolithic stacks that you used to see in the past, like Informatica or Talend, right? Now you can sort of break those apart, write code, and deploy like you would in software engineering. So the practices of software engineering are filtering down to data, both for data engineering and machine learning engineering. At the same time, tools are becoming more plug and play. So you got Fivetran, Snowflake, BigQuery, Firebolt, Upsolver, and any number of companies out there that are, basically SaaS products. Just give them a credit card, give them your data, and get going. In fact, let's talk about that. So who here has seen these charts before? I would say charts, but these graphics. These are the FirstMark Capital graphics from Matt Turk, who works at FirstMark, but he's assembled these charts over the years that sort of show the evolution of the data landscape. So I remember seeing the big data landscape slide in 2012 on the left here, back in 2012, and thinking, wow, there's a lot of products here, right? A lot of these products aren't here anymore. They either got bought, went out of business, or something happened. But if you look on the right now, that's insane. And this is not complete. That's the crazy thing. There's more products out here than I think you can count or get to know. So how would you make sense of this landscape right now, right? If you were to pick tools, how do you decide? Any ideas? Throw them in the chat if you want. So really what data engineering is going to be about is lifecycle management, which I'll get to in this next slide here. I think increasingly with the number of tools here, you can't master all of these, right? I'm sure there's going to be some boneheaded job description that asks for like 20 years experience in all these tools. But really there's so many tools and so many new practices, it's hard to make sense of the landscape right now. So I think so this kind of goes to the future now. We're in 2021 about finishing it out. I'm sure this graph's going to be twice as big in 2022. But what does the future of data engineering look like? I think it's going to get increasingly more abstract, less low-level engineering, but you're still going to code where it's a competitive advantage for you, which means data engineers are going to start adding more value up the food chain, right? So this means doing things that were once reserved for large enterprises, things like data quality, management, governance, ops. This is going to be done by startups, right? And as data scientists, you should be thankful because now you can get better data that you can do your job with. So I think that it's the old saying, data scientists spend like 80% of their time collecting data, preparing it, and so forth. I think what you're going to find is data engineers, given they're going to add more value up the food chain, you're going to see that flipped. Data engineers are going to do all that work. Data scientists get to spend 80–90% of their time focusing on things they do best, which is algorithms, model design and reports and so forth, and less time doing the stuff that they frankly shouldn't be doing in the first place, which is collecting data, cleaning it and so forth. I think there's still something to be said for doing EDA, like exploratory data analysis, or kind of leave that 20% there, but you don't need to be setting up pipelines as data scientists. It's stupid, especially right now. It's all done for you through kind of plug and play SaaS products or open source. And again, I think there's going to be closer collaboration with software engineers, ML engineers, and data scientists, analysts, and other titles yet to be invented. The field of data is still getting started. I'm lucky to have gotten into the field early on and have seen the progression. I just feel like even with the amount of progress we've made, right, it still feels like we're nowhere close to what should be happening. So stay tuned. You're getting into data, I think, at a great time. There's a lot to learn, and there always will be, but it's a very exciting time in data right now. So hopefully that helps you understand what data engineering is. And with that, I'm open to any questions that you have.
Thank you, Joy. Amazing presentation. And
Oh,
if you have any questions, or maybe something that you are already working with data engineering, please, you can ask Joy. He knows everything about data. I'm sure he has the answer, or at least he can guide you or to find some information about the topic. So please, you can, if Joy, they can open the microphone to ask you, maybe. Okay, we can do that. So if you can ask, please open your microphone to share your experience.
Luca asked in the chat, do you think data scientists should learn more on data engineering? I certainly don't think it hurts, but I think it depends on what type of job you have. So if your job depends on you understanding data engineering and more importantly, doing data engineering, then yeah, you should learn about it. But I think it doesn't hurt you as a data scientist to understand how data engineering works. I think it makes you a better data scientist because then you know what questions to ask of the data engineers who are helping you. So good question. Georgios asks, I'm wondering, how can one find his or her way into the tools landscape? That's a great question. I would say the tools landscape is hard. This is what I thought about a lot when writing the book, right? It's like, how do you write a book about a field that's changing very quickly? You've got to focus on the things that aren't going to change. So I could see very few scenarios where a data system stop generating data, when you're going to stop ingesting it, transforming it, and storing it, right? And then serving it for downstream use cases. And so I'd say understand the bigger picture concepts, like how does ingestion work? How what do various generation systems look like document stores, relational databases, and so forth? What are the big paradigms in transforming data, right? Like star schemas, featureization for machine learning data sets, and so forth. And then how do you serve data, right? And how do you store it, and so forth, right? Do you want to sort it in a data lake? Do you want to sort it in a data warehouse? I think if you understand these big picture concepts, everything else falls into place, actually, because then you can understand what tools you should be looking at in the first place. I think if you try and approach it from looking at that slide with all the tools and just randomly picking them, like you're going to go crazy and probably not be effective at whatever you're doing. So that's how I would approach it. Thanks for the comment. Yeah, have a good day. Yulia, I think I'm pronouncing your name right, asks, what data engineer should know to be an associate? I think what you're asking is how do you become an associate level data engineer? understand the life cycle. This slide here, I think it goes back to the life cycle. Again, when I think about the things that this is true in technology in general, right? Like I think to be a good software engineer, you need to focus on kind of first principles, right? Like how do computers work? What does good code look like? Right? How does version control work? And so forth. I think if you can understand the basic principles, the fundamentals, you have a much better time, I think, becoming an associate, mid and senior level. The people I've seen who don't do a good job at their career progression actually focus too much on the tools and focus too much on what's cool at the moment, and don't take the time to really focus on like the underlying concepts and the big pictures that sort of drive the field forward. So I'd find like the important books in the industry and read those. Designing Data Intensive Applications by Martin Kleppman, I think, is still one of the best books for data engineering and software engineering, ever written. So I'd probably read that book. So, and then mine, obviously, but that's not coming out for a bit. So joking. Cool. Any other questions?
I have a question, Joy. What do you think? What do you think are the skills that a data engineer must have to do this role?
I think that they're soft skills, really, actually. I think that, well, communicating is really key, right? So you got to understand like what are the requirements that you're trying to accomplish, right? So that's key. I think building good rapport with teams. So like understanding, okay, so what teams are helping generate the data here? How do I get to know them? Because what happens if a database goes down here, right? You can't get your data anymore. So you kind of want to make friends with these people over here for a lot of reasons. Obviously, you want to understand what the stakeholders of your data want too. So what do data scientists want? What do analysts want? What does the business want? I think that's a really good way to. Those are some of the skills I would say that you would need as an engineer, or probably just in general. Really, like soft skills are good. I know that's something that Gio, you talk about a lot of soft skills, and I think that it's very much underrated actually, because everyone wants to think that it's a technical answer, and I really don't think it is. The other soft skill I will say that you need is the ability to continuously learn and tackle hard topics. The field is changing so much that I can't really tell you, today what's going to be important 2 years from now, except for maybe these underlying things here. So somebody says data architecture sounds like one of the most complex topics. I think it is actually, right? So I think it would pay well to understand, okay, so like what does architecture look like? What does good software architecture look like? What are the underlying principles of architecture? And what are the anti-patterns of architecture as well? What are the things you want to avoid in architecture, for example? And really focus on these big picture areas and understand the big ideas. This, I think, will make you a good engineer or a data scientist in general. Like focus on the big ideas in your field. Like I said, the people where I see they don't do well is when they focus too much on the little things that actually don't matter that much. But the thing is, you won't know what those are, especially when you're starting out. Precisely because you're new, and so everything seems new. So how would you know what a big picture concept is from a small picture concept? But the whole thing is you got to just keep learning, right? I think learning the wrong things is as important as learning the right things, because then you learn what not to learn. So, let me see. Luca asks, what is the best way that a data scientist has to learn more in data engineering? For example, books or some online courses by Google, Amazon, Databricks. At the moment, should you suggest to start from the structured data rather than unstructured? I think it depends on what you're trying to do. Unstructured data is good if you have a use case for it. Structured data is good because it's everywhere, but I think it's also harder in some ways than unstructured data. Like I think image recognition is actually way easier than making a machine learning model in structured data, which for reasons I can get into if you'd like. As far as courses, I can't say I found that many good ones, which maybe prompted me to write a book. I think if you wanted to get a certification, GCP or AWS actually have really good certifications for data engineering, which I think do a good job at assessing your ability to think like a data engineer, but it's within the confines of their cloud. But I would say do it. Like I have a study group right now for the data engineering exam for GCP, and I got people into that cert that study group precisely because people were saying, well, I want to get hands-on experience with these tools. And I was like, well, okay, like it's really expensive if you're going to go, first you have to get a job, and it's really expensive to spin these up. So like, why don't we have a study group where you can get the start and then we can try out these tools. And so that's one way I've approached it now, but it's hard because it's not like you can just spin up like a Python notebook and spin up a giant data pipeline and warehouse, right? It's way different in that regard, where you have a lot of infrastructure. So it's kind of like asking you to spin up, like if you wanted to become a plumber and I asked you for a portfolio project of your plumbing projects that you've done, it'd be really weird, right? Because it's like, are you gonna, put pipes in like a house? Like that's kind of the same thing with data engineering though, in this way, where it's a different approach. That's a lot more hands-on and I would say there's a lot more heavy lifting. So, but with the cloud, it's nice because you can just spin things up and destroy it real quick. And so just don't leave it on forever. You'll lose a lot of money. Reito asks, which cloud platform will be the leader for data engineer in the future? What is my opinion? Because I work with all the clouds, I can't really have an opinion on this. I do actually have an opinion. But I work with all the clouds except for Azure, and this includes Snowflake. And I don't know that any cloud, honestly, I think from a market share standpoint, Azure is going to be the biggest cloud when everything's said and done. But that's because if you look at who runs Windows workloads, it's all these companies that still run Windows on-prem, in their own data centers, and moving to Azure is incredibly simple. So I think, realistically, Azure is going to be the best one. But for a data engineer, that's a hard question. I would say because of the rise of multi-cloud as well, which means you can operate in various different clouds all at once. It's not a straightforward answer, actually. I would say that you should understand the basics of all the clouds, actually. So, and how they interoperate. I would say get good at one cloud and then try and expand those concepts to the other clouds, because you will come across all of them. So I kind of dodged your answer at your question, actually, but probably for to be polite, but I think that it's a good answer. So what other questions you have?
Yeah. Feda, I think you have a question. If you want to open your microphone. Yes.
Yeah, I was going to write it. Thank you for this presentation. It's an interesting subject. I'm a data scientist, and I agree with you. Like, we should understand, as a data scientist, we should understand the concept of extraction, the data and transformation. But I don't know if you agree with me. Like, we should understand the concept by not practicing the tools itself. It's more to program so that it's like delivering the concepts. So I don't know if you have like any recommendation regarding like practicing the concept. I know I program usually in Python. So lately I find my treasure by having like a Kidro open source, like a framework that allows you like to have the concept of data engineering. But I don't know, like, and it helps me a lot in putting my models in production. But I don't know if there is another tools or another recommendation of enhancing the practice.
So what are you trying to do? Are you trying to extract data?
Yeah, I already integrate this in my code since the beginning. So I'm not like I'm not using Jupyter. I'm doing like the code from extraction until like production. So
I would say there's some really good packages out there. Airbyte's one where you can do extraction from a variety of data sources, from databases, APIs, and so forth. And that's open source, right?
Yeah.
So that's great. Meltano is another one. They just actually spun out at GitLab a month or two ago. So I'd check out Meltano and Airbyte for extraction.
Okay.
Yeah, those are both great.
I'll try that. Thank you.
Yeah, of course.
Joyce.
I have another question. Yes. Hi, Joy.
Hey, what's up? Hey.
I should disclose that I'm part of VMware's data analytics team, just so everybody knows. Yeah, we have our data analytics platform internally in VMware, and we've actually started open sourcing one of our data engineering frameworks. I won't disclose it at this time. But as part of that effort, we did research which showed that a large number of data science work is actually data engineering work. And as you mentioned earlier in your talk, very few people have managed to actually put something into production. A great amount of projects die off because they couldn't, as you mentioned with the pyramid, they try to go straight to the top. They figure out the data engineering work is too much and they fail, essentially. So I wanted to ask if you have, have you found a formula which works, or a set of frameworks which used together usually manage to produce a good result? So something which encompasses the whole data engineering lifecycle and it is able to quickly get customers up to speed. I do understand with scale and with increasing the volume, you have to iteratively make adjustments, of course. But do you have any observations on that subject?
Yeah, that's an interesting question. I see a lot of, and there's sort of this parallel universe right now with the MLOps world. If you haven't joined the MLOps community, you should totally do that. They have a great Slack group. It's mlops.community. And that's cool. But what you'll find when you talk to people in that community is it's still a very open-ended question on the best way to deploy models to production. I don't think it's been answered yet. I think there's a few good frameworks out there that are starting to be developed. Dan Jeffries over at the AI Infrastructure Alliance, he's working on something like that along with several other, in partnership with several other companies and people. And I think that's as good of a place as any to start. But there's not really one framework I've seen where people have said, "Oh yeah, that's the one. Let's use that." Like that's still very open-ended.
I'm not referring to necessarily AI and ML use cases only. Even for, let's put them, smaller scale projects like operations, dashboards creation, and reports and stuff like that. We've seen people use a myriad of options. DBT and Airflow are usually a common option. We have our own framework, which we're open, as mentioned, but this we are quite uncertain whether this is going to work actually. And from your practice, have you seen, I don't know, do you know what are the most commonly used tools that actually manage to get people to production?
Yeah, I mean, if you're talking about data, irrespective of data science or just analytics, I would say the modern data stack is very popular. That tends to include something like a Fivetran or some sort of ingestion layer. Airbyte, I think, is another one. Snowflake's a huge, popular data warehouse, but I'd say BigQuery is like the second one that we see a lot in Google. DBT is definitely the transformation layer that I see a ton of. Oppositely, surprisingly enough, a lot of people are using like Matillion or those kind of tools as well, Glue and whatever else is in the cloud. So it really depends on your workloads. And I see a lot of people just orchestrating transformations just using Airflow, just kind of bypassing everything. So it just depends on what your workload is and what your team is. But some combination of that, I think, is kind of, modern data stack-ish is what we see a ton of. Like this is the United States, obviously, is what I'm talking about. Globally, I suspect it's very similar, though, talking to people around the world, as I do a lot. And
I believe so, yeah.
Yeah, it's not much different. But yeah, it's some combination of that. Yeah, and that tends to be the sort of the stepping stone into then doing data science down the road, which again is sort of an open-ended question. But yeah, it's a good question, and I think it's important for a couple of reasons, because what we're talking about is a data stack of today, but I don't know that if that's a data stack of tomorrow. So
yeah, definitely. And I wanted to ask, in your book, are you going to provide some common patterns for doing these things?
Yep, definitely. Yeah. Actually expect a chapter on that soon. So
okay, awesome.
Yeah, awesome.
Thanks.
Good questions. Yeah, of course. Let me see. Sean asks, and I have a couple of minutes left. I have to hop to a meeting in a second. These are good questions. I like this. Good group. For analysts wanting to develop their skills, should they focus on becoming a data engineer instead of focusing on the currently hot popular data scientist roles, in my opinion. Thanks. Careful what you ask for on this one. So I think that data science as a term is very, I'm confused by it, honestly. I don't know what, I never knew what data scientist meant when it first came out as a term. I think it was in 2009 when it first came out by DJ Patil. I'm still confused. There was Drew Conway's Venn diagram of like a data scientist is somebody who's really good at hacking together stuff, knows statistics and has domain knowledge or something like that. I don't know that that applies anymore. And I also see people kind of lumping in analyst into data scientist, which I do because I'm like, I don't know what data scientist is, therefore it's everything. But I think your question is, do you want to focus on becoming a data engineer instead of focusing on data scientist? I think it's really an individual answer. Like I can't answer that for you any more than I should tell you to become a hockey player or a ballerina or a figure skater. Like I think that is really a subjective. I'm not saying that data science or data engineering is one or the other in this case, by the way. But what I am saying is I think that's very much a personal preference, and you should just choose what your long-term goals are. I can tell you the anti-patterns I've seen with career advice. If I told you that you should only follow the money, right, and go for the jobs that's going to pay the most, that only turns you into a mercenary. And then, so if you really wanted to make a bunch of money, you'd probably go into crypto or something, right, or become a ransomware hacker or something. So assuming that that's, or still drugs or something, but assuming you don't want to do that, and you want to work in data, I would say find the work that's fulfilling to you. That the litmus test I would use too is what would you spend most of your time studying if you had to, right? Because you're going to be doing that a lot. What would you spend a lot of your time talking to people about? Because you're going to do that a lot too. I think that should answer your question. There's not really a right or wrong answer here. At some point, I predict the term data engineer is going to go away.
Awesome.
Yeah.
Joy, I think it's necessary to have the right mindset. I think this is when I remember I asked someone about data engineering before knowing you. They tell me it's necessary a good mindset. Then the rest you can just learn the tools, but the mindset is the vital. So
yeah, it's everything.
Yeah.
I mean, the people I found who are really successful in their careers, they do something that they just like to do and it doesn't feel like work. Like I'm in a field, I've been in data. I don't think I've had like a non-data job, since I started. I mean, maybe some more kind of, maybe it's some roles that overlap with business a ton, but I think that actually makes you better at data. But I don't think I've ever had a job where I wasn't doing data. And that's by design. Like I've always liked it. And it's just a field I've always been in. And it doesn't feel like work. I think it's just general career advice. If you find the job that doesn't feel like work, because then you're going to last longer. The people I see getting burned out are the ones who I think getting to a field because they think it's the hot thing at the moment. And when it's not hot, then you're just going to, go to the next hot thing, and who knows what that's going to be. So.
Yes. Okay, Joy, I know that you have to run to your meeting.
Yeah.
Thank you so much for this time.
Yeah, thank you, everybody.
Thank you so much. And please, if you want to follow Joy, he has an amazing YouTube channel. He's talking about amazing things there. Please follow him. I have left the links on the chat. And thank you, everyone, for coming. We are going to organize future events. So please follow us in the Meetup and see you in the next Meetup. Thank you so much. Thank you again, Joy.
Italy. All right. Okay. I have to do that. All right. We'll see you guys.